This is the intro to angles of rotation, which is basically circle trigonometry, which could sound kind of weird because trigonometry being the circle of or the measurement of triangles. What does it have to do with circles? Anyway, but we'll get there. So these are angles of rotation, and some lines got cut off, so I'm gonna just redraw them. But so this is just like a regular graph. This is your x-axis. This is your y-axis, regular coordinate plane, and we can make what's called an angle of rotation by basically just we always start on the positive x-axis right here. It's called the initial side, and then how many of our degrees our angle of rotation is basically how far we have to go. Um, and wherever we stop, that's going to be our terminal side. The angle that's created by these two little sides that we're calling um, is your angle of rotation. So let's say we have 135 degrees. That's our angle of rotation. We need to move 135 degrees. How far is that? That's kind of hard to tell, but we know that if we don't move at all, we've moved 0 degrees. Okay, we always start at this spot. It's always the positive x-axis spot right there. That's the initial side. Always starts there. Your angle is created by your initial side and your terminal side. We're going to go 135 degrees. Well, I know that if we go straight to the y-axis, so like that's this far so far, if I go right there, that's got to be 90 degrees because, it makes a right angle, a number of other reasons why that would have to be 90, but somewhat obvious. So this would be 90 degrees. And then we've already gone 90, so we could figure out that that's like 45 more degrees we'd have to travel. And that pretty much puts us right in the middle uh, of this quadrant. And so we could draw our terminal side here. But ultimately, that right there, this angle, like this angle measurement that is created by the initial side and the terminal side is 135 degrees. One important thing is it's positive. This is a positive degree measurement. So we can have negative degrees now, but positive degree measurement in angles of rotation is going to always be uh, counterclockwise, meaning that if this thing were a clock, positive angle measurements go backwards clock style. So it would be going up. We're always going up if it's a positive degree measurement. We would always be going down if it was a negative degree measurement, which would be clockwise, but we'll get there as well. The main thing right now is to know that an angle of rotation is just created by an initial side and a terminal side. And however, whatever your degree measurement is, that's how far you go. And we're always pivoting around the origin. Okay. Um, this also kind of has to do with quadrants since we start in this the initial side's always on the positive x-axis spot. Uh, from 0 to 90 degrees, meaning that, if we started right there, we ended at 90 degrees, that's the y-axis, that quadrant created is the first quadrant. And then as we continue around going counterclockwise, like in a circle, like rotating this thing, we'd be in the second quadrant, would be from 90 to 180. And then from 180 to 270, that's your third quadrant. And 270 to 0 or 360 degrees, that's a full circle, is your fourth quadrant. So if you've ever wondered why the quadrants are labeled, kind of in that order, that's one possible reason. Okay, so let's see. What do we miss? These are some good benchmark angle measurements to know that if my terminal side ended right here, the initial side is right here, and the terminal side is right here, that's 90 degrees. If it went, if it ended right here, meaning my angle then goes, all the way across, that's 180 degrees. So basically just increments of 90 degrees ends up, here's 270, ends up being at 360 for one full circle would be 4 sets of 90 degrees. You'd end up with 360. So just some more just information, but really we haven't done much other than talked about this is just kind of the layout of an angle of rotation, or how to think about a graph if we're talking about angles of rotation. Here are some things we could practice, I guess. We could pick an angle measurement between negative 360 and positive 360 degrees, meaning really I just don't want to do more than one full rotation because it's kind of pointless for us right now. But let's say we'll do this one here. Just pick one. How about 100 degrees? If I'm doing 100 degrees, start at your initial side, okay? And I don't really know where 100 degrees is exactly, but I know that it's like 10 degrees more than 90 degrees. And I know that 90 is right here. So I would say that my 100-degree angle of rotation probably be somewhere like over there. So I would just draw this. It's kind of like a piece of a pie or a pie chart or something, but really it's your angle of it's the angle that's created by the terminal side, the initial side, which is that many degrees. So that's what I would say a 100-degree angle of rotation is. You could try, just for fun, let's do a negative, I don't know, 70. Negative 70 degrees, we still start at the initial side. So positive x, still start there, but it's because it's a negative degree measurement, we are no longer moving upwards, we are moving downwards. So, and we can use a little bit of logic here. This is, if I travel in a negative direction, I still start at 0 degrees. This would then be negative 90 degrees down there. This would be a negative 180 degrees, and this would be negative 270 degrees, and this would be also a negative 360. So 0 and negative 360 represent the exact same spot, just as 0 and positive 360 would. But in any event, we're going negative 70 degrees, so we have to go down from the initial side. And I don't really know exactly where this is on here. It doesn't have to be precise, but it should be in the ballpark here. It's, negative 90 is right here, the y-axis. So I would say negative 70 is, kind of close to that. It's 20 degrees away. So maybe it's like, right there. So that would be a negative 70-degree angle of rotation. And I don't know, make up something like the 310. 310 degrees is positive. So starting at the positive, still initial side, always start there. So 0 degrees is. Now, I know certain things. I know that this is 90, so it's got to be well past that. I know that this is 180. I know that this is 270, so it's well past all of this. And then this is back to 0, it's 360 degrees. So, I know I'm going to be past 270. I can kind of subtract it off, be like, well, if I travel 270 degrees already, how much farther do I have to travel? About 40 more degrees. So I just did 310 minus 270, but we don't really need to worry about like, oh, what am I subtracting? We just need to figure out roughly where the location would be. Here's 270, and then about 40 more degrees. Well, I know that this whole span right here is 90 degrees. So 40, just a little bit under half. It'd probably be somewhere right over there or so. So this angle of rotation, 310 degrees, it's approaching a full circle. It goes all the way around like that. Okay, so these are how you draw angles of rotation. And I just picked some random numbers, didn't really matter. Key piece of information, make sure you know that if it's a positive degree measurement, we're moving upwards. We start up from the initial side. If it's a negative degree measurement, we start down from the initial side. And then our terminal side is really just this other piece, this other segment that we draw to give us our angle. Okay. This also did not get finished, it looks like. All right, well, we know there's something called coterminal angles. And what a coterminal angle is, so this is a little bit of vocabulary, and there'll be a little slide later about it. Okay, so what this is saying is that coterminal angles are angles that end at the same spot. They may show like they look like they're different degree measurements. So, we would think, okay, well, they're different angles. But coterminal means they both end at the same spot. Terminal, terminate, co, like both, kind of. So if I went 131 degrees, for instance, that would leave me somewhere from the initial side, somewhere over here. So that's this distance right here, positive. We went up, whatever. If I did negative 229 in red, that would be going from the initial side, going down. There's negative 90. There's negative 180. This would be negative 270, and that's too far. So I would, negative 180, I'm guessing go 49 more degrees. That's about right there. So what we notice is that in this particular instance, both of these angles end at the same spot. So in effect, wherever they end, if they end at the same spot, they are called coterminal angles. One other way to figure that out, to know if they are coterminal or not, is very simply to just take an angle measurement, like 131, and if I want to know a coterminal angle to that, all I have to do is either add or subtract 360 degrees. Because if you think about it, if you're at one spot, right here, and then suddenly you decide to go 360 more degrees from here, you're right back where you were. That's a full circle. So if I added 360 degrees to this, this would be, 491. That means that 491 degrees, granted that is more than 360, so it's more than a full circle, but this would be coterminal to 131, coterminal to 131 degrees. Because 491 would be like, okay, well, here's 360 degrees of it, and now 131 more leaves me right there. Similarly, if I had 131 and I subtracted 360, what that's actually asking me to do is to say, well, I want to, if I were at 131 degrees and I subtracted 360, it'd be like going a full circle backwards. I would go this way. Okay, this is going far, and then we're right there. Now we've gone a negative 360 degrees. Where are we? So we were at 131. We went 131 backwards. So you could subtract that off, and then you'd have to go negative 229 more to do that. Or you could just add this up, subtract it off, and get negative 229. This all could be quite confusing until you really get the hang of it. The only thing that really matters here is if you want to find a coterminal angle, just add or subtract 360 degrees to whatever angle you got. If you add or subtract 360 degrees, you will get a coterminal angle to that angle. So we could practice it pretty easily, but here's some vocab. Coterminal angles are two angles. There's usually one positive, one negative that end in the same place. Okay, that's true. However, you could have an infinite number of coterminal angles. Because what if I added 360 degrees like twice? What if I added it, 3 times on my angle or on my graph here? If let's say 45 degrees was my angle, that's like about right there. And then I wanted to add 360 to it. Well, that would basically be right there. So this would be, 45, but then plus another 360 is 405. 405 is coterminal to it, to 45 degrees. And if I added 360 again, all that's really happening is that just go around again, end at the same spot, That's what another 360 is, 765. So if we just started, I mean, we could tell that this is exactly the same spot. 765 would be do 2 circles and then end with 45 degrees. So you can have an infinite number. You can just keep on adding 360 or keep on subtracting 360. We also know that angles of rotation, we've learned that if it's with a positive degree measurement, they are counterclockwise, meaning we start at the initial side and we go up. Negative degree measurements, we start at the initial side and we go down to wherever. We go clockwise in this case. There's one more thing we need to talk about, but we can practice this quick. Find the coterminal angles for the angles below. They want you to find one positive and one negative, essentially. So 25 degrees, or let's put it this way. A lot of times we're asked to keep our coterminal angles between negative 360 degrees and 360 degrees. So if I were to add 360 degrees to 25 here, I'd be more than one full circle. So maybe whatever, in this case, since it's already positive, I'd subtract 360. We'll see where that gets us. But if I subtracted, you're going to get negative 335 degrees. So that would have you start out right here, negative 335. So this is going to go all the way backwards till we get about 25 degrees away from a full circle. So something like that, which, as we should presume, knowing the coterminal angles are the same spot, same ending spot, that 25 degrees would have been, initial side, there's my terminal side, we went 25 degrees. End at the same spot. 800, it's a fun one, because if I wanted to try and find a coterminal angle, I could subtract 360 because it's got too many extra rotations, like full rotation, full circles. I don't need to do that. Subtract 360, that's going to get me down to 440. But that's still more than a full circle. So I could subtract 360 again. That's going to get me down to 80. All right, 80 degrees. That's within one full circle. We could find that. Start here. It's positive, so we just go up 10 degrees away from 90. About like that. And this is a good coterminal because we eliminated 2 full circles that we would have had to draw to draw 800. We'd have gone 360, 720, and then another 80. But we didn't need to do that. So 80 is a coterminal. A coterminal of negative 155. In this case, I would add 360. Because if I subtracted 360, it's going to be a bigger negative number, more than negative 360. I can also if I draw this first, I could kind of get a picture where this is. Negative 155. Start here. Negative 155 past negative 90. Approaching negative 180. And so it's somewhere over there. Or if I wanted to do a positive coterminal angle, like what angle would this be if it were positive, ending at the same spot? We could, add these together here, and you get 205. Which should make some sense because here, negative 155, we were 25 degrees away from negative 180. And in the same context, if we have 205 degrees, we would start the positive initial side. We'd go past 90 positive, past positive 180, and then 25 more degrees is 205, and we'd end right there. So that's what makes these coterminal. They end at the same spot on the circle. Okay. This is the last part, and it is the most important. So this is not like coterminal angles any longer. These are called reference angles. A reference angle is an angle that is formed by the shortest path to the x-axis. We do not care about the y-axis. Only the x-axis. Shortest path to the x-axis. So, in this case, we have an initial side here, and then it goes around, and then we end up at 220. So we're saying if we had the degree measurement, 220. The closest x-axis, the x-axis is the left or right one. This is 0 degrees over here. This is 180 degrees over here. This is also 360 technically, but either way, the closest x-axis would be 180, right? That's the degree measurement of the closest x-axis. So we would really just, all we have to do is figure out how far it is to the closest x-axis. In other words, 220 minus 180. Or really just how far do you have to walk? We would have to walk 40 degrees. That is your reference angle. Reference angle, again, just means we're referring to we want to use the x-axis, the nearest x-axis as a reference, like how far are we away from that x-axis? That's all it is. But since we're talking about like a path or like a distance away from or towards, it's always going to be a positive number. Even if you subtract and you get a negative, it's really just saying how far are you away. So we are 40 degrees away. It's always a positive number. We could practice that for a moment. Here are some angles we could find the reference angle for. So first of all, 45 degrees, we could draw that angle first. And 45, that's like right here. So that's this angle. Now, one important thing to realize is the only x-axis angle measurements that we're always going to be referring to, no pun, 0 degrees and 180 degrees. So basically, the only 45 is pretty close to 0. The only one it could be close to that we would try to check would be 180. And clearly it's closer to 0 degrees than it is to 180. So we would just say, well, how far is 45 degrees away from 0 degrees? 45 degrees. So the degree measurement, 45 degrees, its reference angle is 45 degrees. Just how far are you away from the closest x-axis? Never the y. We don't care about the y. Okay. 140 degrees. You could pause the video and try this. Good pause. Okay. So 140 degrees is helpful to know where this is. Initial side starts right here. To draw 140, we would have to go past 90 degrees. And then, like 50 more degrees. So it's kind of somewhere over here somewhere. Relatively. Then what this is saying is how close are you to the closest x-axis? And this is 0 degrees. This is 180 degrees. Clearly we're closer to 180. And so just how far away are we? It would take us 40 more degrees to get there. So 40. That is your reference angle. Again, it has to be positive. Okay. And you can have a negative degree measurement. We're just going clockwise then instead of counterclockwise. So we start at the initial side. Again, same positive x-axis start spot. Negative 100 degrees, we'd have to go past the negative 90. It's like the y-axis, and then only like 10 more degrees. So we're down here somewhere. Okay, again, negative degree measurement. So we went in the clockwise direction. The reference angle then was we just want to know how far away is it from the closest x-axis. Well, since we basically passed the y-axis here on the way, we're now closer to the next x-axis. So it's over here somewhere. And we just need to know how far it is away. Well, I know that if this was negative 90 and I'm at negative 100, I went 10 degrees past that. And every quadrant is 90 degrees total. So I've got to be, 90 degrees minus 10 that I already traveled closer to this x-axis. There's a number of ways to think about this. One of them would also be that this is, the negative 180 degree measurement. How far is negative 100 to negative 180? 80 degrees. Again, and we're talking about paths traveled. How far do you have to go? It's always going to be a positive number. So we'd say it's 80 degrees is the reference angle. It's 80 degrees away from the closest x-axis. That kind of begs the question, what's the largest reference angle you could have? What's the maximum reference angle? So, let's say we have a graph, and here's our initial side, and the maximum reference angle. So that's going to be as far away as you can get from the x-axis. That would be maybe somewhere like right here. As soon as we get to this 90, we are we are 90 degrees away from 0. That's true. We're also 90 degrees away from 180. And as soon as we go like 1 degree past that, now we're closer to 180. And it would be 1 degree closer, so 89 degrees. If we were a little bit on this side, it would have to be less than 90 degrees and would be closer to the 0. So the maximum reference angle you can have, the farthest away from an x-axis you can get, is 90 degrees away. And then what is the minimum reference angle? It's a good question, I guess. If you had an angle that was, let's just say 180. 180 would be like this. Our terminal side is ending right on the axis. This is 180 degrees. How far is it away from the closest x-axis? Well, the closest x-axis is 180 degrees, and it is on it, so it doesn't have to travel anywhere to get to it. So subtracting those, I would get 0 degrees. The reference angle in this case would be 0. Okay, 3 things then. One, we should know how to draw these. Just draw a little, doesn't have to be perfect, one of these, and just go that many angle measurements or degrees in which direction. So negative 135 would be starting here, negative about halfway between those two. I went past negative 90, but I got to stop before I get to negative 180. If you have a degree measurement that's like 450, that's more than a full rotation. You don't have to sit there and go, okay, let's 1 full circle, and then how much more? We could use its coterminal angle. Although technically, if it wants us to go 450 degrees, that is 1 full circle and then another, 90? So either way, it's going to stop right there. Ultimately, you'd have 90 degrees would be acceptable to draw that angle because they're coterminal. Same thing here. Now it's just ugly. You're just going to rotate like 3 extra times. Find the measures of positive angle and negative angle that are coterminal with each given angle. Just basically add and subtract 360 to each of these angles. Those will give you 2 more angles. If I add 360, or if I subtracted 360, I'm going to get an angle measurement that is coterminal with it. It ends at the same spot. And then a reference angle, you can visualize this where it's at on a graph, 95. It's going to be like right there. It's closer to 180. How far away is it? That's your reference angle. I guess that's about it. All right. Good luck, and let me know how it goes.